Section 2.6, Absolute Value Inequalities. We've already looked at how to solve absolute value equations, and we're going to use a similar process to solve and graph the solutions for absolute value inequalities. Let's start off first with some really basic examples. The absolute value of x is greater than 5, and then separately, the absolute value of x is less than or equal to 3. We want to figure out what numbers would make the first inequality true. So let's start by putting a number line in front of us. And so now the question is, what part of this number line will satisfy that inequality? What are the values of x I can plug in and make the absolute value of x greater than 5? Well, I guess that would work if x was positive and it was anything bigger than 5. Certainly 5 itself won't work, so that'll be an open circle. But then anything to the right of that, going on forever, would have an absolute value that's bigger than 5. The same thing could actually be said, if you think about it, for the negative values of x as well. I could start at negative 5 and not include that, but then go to the left and include everything else over there. All of those negative numbers are big negatives, and so their absolute value is greater than 5. So what we have here is a typical looking OR problem. And we could rewrite this absolute value inequality in two different inequalities, connecting them with OR. And so this is what we can expect. If we end up starting with an absolute value that's greater than a positive value, in this case 5, we can split this up into two different inequalities. One where x is less than negative 5, or x is greater than 5. And our graph will look something like this. And this is always going to happen when we have a greater than in our original problem. All right, let's take a look at the next example. Absolute value of x is less than or equal to 3. So let's get another number line up there. So now what we're looking for is the points on this number line where the absolute value of that number would be less than or equal to 3. So certainly the absolute value of 3 is less than or equal to 3. So I'll put that in. Same thing with negative 3. The absolute value of that becomes positive. Now what other numbers would have an absolute value less than or equal to 3? That'll be everything in between here. So this is what this looks like here. And that's actually what would typically look like in AND inequality, combined inequality. So I'm going to rewrite this as two separate inequalities connected with the word AND. And so we could write this inequality by saying that x is greater than or equal to negative 3 and x is less than or equal to 3. And certainly because it's an AND problem, I could write it in my sandwich notation, putting the x in between, and say that negative 3 is less than or equal to x, which is less than or equal to 3. X here is between negative 3 and 3, inclusive. That's why I filled this in. And so what we have here is we have a less than or equal to, which becomes an AND problem. And that's always going to happen. An absolute value is less than something, or less than or equal to. We're going to be working with an AND situation. And so there's a little way to remember whether we're working with or AND, and this is what you can use. It's called Gore Land. So pictured here is Al Gore, who was vice president under President Bill Clinton and ran for the office of president in 2000, but ultimately lost to George W. Bush. Now, when he was running for president, Al Gore decided that he would rename the country if he was elected. He said that he would rename the country Gore Land in his honor. Now, that's not really true, but it is a funny little way to remember this nice, helpful little trick. When you have an absolute value inequality and it says that it's greater than or equal to, it doesn't matter if it has that or not, a positive number, then when you solve it and you split it up, you're going to get two different inequalities and they're going to be connected with OR. The connection there is that greater starts with a G, and that's connected to OR. G OR makes Gore. Similarly, when an absolute value is less than or equal to a positive number, we're going to split it up and form two inequalities with the word AND. We're going to connect them with an AND. And so that's a less than, starts with L, and that's connected to AND. L and land. And so we have this connection to Gore Land, which brings us back, and if we write it in a nice way, because it's kind of ugly here, write it in a nice way, brings us back to Al Gore Land. The new name of the country had Al Gore been elected. Again, that's not a true story, but it may help you remember that when you start with a greater than, you're going to connect them with an or. If you start with a less than, you're going to connect them with an and. All right, so let's take a look at a couple of these problems. So here I have the absolute value of 3x minus 5 is greater than 6. I'm going to solve this in a very similar way to the way I would solve an equation featuring absolute values, but with the inequality, just going to have a little bit different. First of all, I split them up into two different inequalities. Starting with 3x minus 5 is greater than 6. It's exactly the same as the original, but without the absolute value symbols. In the second one, it starts exactly the same, 3x minus 5, but then there's two ways that the second inequality changes. First, I have to multiply the right side by negative 1. So 6 multiplied by negative 1 becomes negative 6. And that's something we did when we solved an equation. The other thing I need to do is I now need to flip the inequality symbol. I started with a greater than. I'm now going to become a less than. So I have my two inequalities, and I know I have to connect them with a word. I'm going to connect them using Gore Land. I'm starting off with a greater than problem. Greater than means I'm doing or. So I'm going to connect these with the word or. That tells me that I already know what the final graph should look like. So go ahead and solve each inequality and graph on a number line, and then come back and check your work. All right, how'd you do? All right, so here we end up getting x is greater than 11/3 or x is less than negative 1/3. And that on the graph looks like a typical OR problem. We wanted it to be an OR, so we don't need to look for overlap or anything like that. And we have it. Now if you have a number line with markings already on it, you know that negative 1/3 would be between 0 and negative 1, closer to the 0. And 11/3 would be 3 and 2/3. So between 3 and 4 and closer to 4. All right, that's with a greater than. What if we start with a less than? All right, so starting with a less than here, we're going to do exactly the same thing that we did in the last case. I'm going to start by splitting up our inequality into two different inequalities without absolute value bars. The first one is exactly the same as the original without the absolute value. The second one, the left side stays the same, but then we do two things. We make the 2 into a negative, and we flip the sign. Now, I have to look at Gore Land, and for this I always look at the step right before I split, and that's a less than. Less than tells me I'm using and. So for a less than problem, I'm looking at an and. Now we'll go ahead and solve each of these, and this is really quick so we can even just show those steps here. It's actually the same in both inequalities. We're going to get x is less than or equal to negative 2, and x is greater than or equal to negative 6. And so you can leave your answer just like that, or if you'd like, negative 6 is the smallest one. That's less than or equal to x, which is less than or equal to negative 2. So either of these would be acceptable. And now to do the graph, we know what to expect, negative 6 to negative 2. Now this is an and. Because it's or equal to in both cases, I'm going to fill in the circles. And then x is greater than or equal to negative 6 would come to the right. X is less than or equal to negative 2 would go to the left. And again, it is an and, so I'm interested in where they overlap, or specifically where they connect. And that's the graph that we would have for this problem. So for absolute value inequalities, we split them up. We make the right side negative. And we flip the inequality in that, the inequality symbol in that inequality on the right. Then we solve and graph, connecting them with and or based on Gore Land. All right, enough of me. Now it's time for you to try. Alrighty, here are two problems for you to try. Do them both now, then come back and check your work. How did it go? Okay, so let's just review. First example here, absolute value of 2x minus 5 is less than 7. So we do a little split. Drop the absolute value bars. 2x minus 5 is less than 7. 2x minus 5 is flip the inequality to make it greater than. Make your 7 negative. And because this is a less than, use Gore Land, L and, gives us an and. Solving each inequality will give us x is less than 6 and x is greater than negative 1. You could write that as negative 1 is less than x, which is less than 6. And this is what the graph would look like. Negative 1 to 6, open circles at each, and connect them. A typical and. And then our next one, absolute value of 4x plus 3 is greater than or equal to 5. So we split them up, drop the absolute value bars, start with 4x plus 3 in both cases. Greater than or equal to 5, flip the sign, less than or equal to negative 5. We started with a greater than. Think about greater than is G, Gore Land, and have our or. Solve each inequality. We get x is greater than or equal to 1/2, or x is less than or equal to negative 2. Graph that on the number line, negative 2 and 1/2. Close circles because of the or equal to, and the arrows point away from each other, just like we'd expect for an or. All right, so there you go. That's your 2 examples. Let's try 2 more. All right, 2 more examples for you to try. Go ahead and solve and graph each of these, and come back and check your work. How did it go? All right, and so here we are. Once again, we just split each of these inequalities up, in each one, and the second inequality, flipping our inequality symbol and making the number negative. If we start with a less than before we split, then it's going to be an and. If we start with a greater than, it's going to be an or. Gore Land. G or L and. Anyways, you go through and solve. Remember this notation, the upside down U meaning and, the regular U meaning or. You get x is less than or equal to 2 and x is greater than or equal to negative 1. Also written in this notation, negative 1 is less than or equal to x is less than or equal to 2. And we have our graph. And then the other example, I kind of just threw this in here because I want you to realize that decimals and fractions aren't a bad thing. X is greater than 5.8 or x is less than negative 0.6. We didn't do anything wrong. Decimals just happen. And so on our graph, we have open circles at each of those locations and the arrows pointing out like a typical or. So there you go. Hope that this makes sense, and I hope that you feel comfortable solving these problems. Nice work.